The year is 1976. Radio operators across the globe are picking up a mysterious signal. It's a rhythmic tapping noise, a repeating tick, 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 like a persistent woodpecker pecking at a metal roof. The only problem, there's no woodpecker. The sound is coming from somewhere beyond the horizon. Sometimes it's faint, sometimes it's loud enough to interrupt broadcasts and jam communications. Experts are baffled. No one knows where it's coming from or what it means. So people start calling it the Russian woodpecker. For years, the source of the sound remains unknown. People come up with all kinds of theories. Was it a new Cold War weapon? A bizarre form of communication? A Soviet weather machine? Even a mind control device? Then, in 1983, satellite images reveal the truth. The sound is coming from a massive over-the-horizon radar system deep in the Ukrainian forest near the city of Chernobyl. This is the so-called Duga radar. And though we now know what it is, exactly what it did, and why, it's still a mystery. In 1976, the first reports of the strange tapping noise came from radio amateurs. These hobbyists use amateur radio, or ham radio, to communicate with others around the world. They try to make contact with different radio stations, exchanging information and building international friendships. But one day they pick up an unwelcome visitor on their frequencies. Someone or something is tapping out a Morse code-like rhythm. Tick, tick, tick. At first, it's barely audible, but then the signal starts to grow stronger. At first, radio amateurs assume that the noise is coming from somewhere in Russia, perhaps a construction site where workers might be tapping against metal supports. It sounds like a woodpecker, hence the name Russian woodpecker. But soon, the tapping noise is heard by others, scientists and military personnel working for NATO. Their first concern is that the noise is a new Soviet weapon. Perhaps it's a sonic weapon that can destroy buildings or disrupt electronic systems. Or maybe it's a new way to communicate with submarines under the Arctic ice. Whatever it is, it seems to be coming from somewhere between 50 and 60 degrees north and 100 degrees east, which points directly to a large area of the Soviet Union. The Soviets deny any involvement. They claim that if anything, the noise is coming from American satellites. So the search for the real source continues. In 1979, the British scientific journal New Scientist publishes an article about the Russian woodpecker. It notes that the tapping noise seems to be coming from a single source, but that source could not be found. The noise seemed to come and go with the wind, suggesting a mobile source, yet there was no evidence of vehicles or human activity in the area. Whoever or whatever was responsible was careful to stay hidden. But one thing was certain: the source of the tapping noise was massive. Like I said, at first the sound seemed to be coming from multiple locations, but this turned out not to be true. The tapping noise was picked up on widely separated longitudes from Argentina to Finland, from Hawaii to Turkey. All these signals were actually coming from one place. To understand how scientists figured this out, we need to talk about the science of radio waves. All electromagnetic radiation travels in waves. Visible light, microwaves, X-rays, gamma rays, they're all made of waves of varying frequencies. The frequency of a wave determines its characteristics. Higher frequency waves have shorter wavelengths and lower frequency waves have longer wavelengths. For example, a typical AM radio station broadcasts at around 1 million hertz, giving its waves a wavelength of about 300 meters. Typical FM radio stations broadcast at around 100 million hertz, giving their waves a wavelength of about 3 meters. Now, our atmosphere has an effect on these radio waves. It absorbs some and reflects others. For example, high-frequency waves are absorbed by the ozone layer, so they can't travel very far. Low-frequency waves, however, pass through the atmosphere into outer space. And that's where things get interesting. You see, out in space, there's a thin layer of charged particles called the ionosphere. These charged particles reflect low-frequency radio waves back toward Earth, and this reflection allows radio waves to travel great distances. This natural phenomenon is called skywave propagation. and it's what makes long-distance radio broadcasting possible. But here's the catch. Because the ionosphere is in outer space, it's affected by solar winds and magnetic fields. This means that the ionosphere's ability to reflect radio waves isn't consistent. One moment, radio waves can bounce off the ionosphere and reach someone halfway around the world. The next moment, they're absorbed by the atmosphere and can't travel more than a few miles. To get around this problem, radio operators use high-frequency radio waves. These waves don't rely on the ionosphere, so they're much more reliable. But this comes at a price. See, higher frequency waves can't travel very far. If you want to send a radio signal more than a few hundred miles, you need to use low-frequency waves. And low-frequency waves are much harder to detect. You need a massive receiver to pick them up. That's why most people aren't aware of low-frequency radio waves. It's hard to detect them without the right equipment. But if you know where to listen, you can hear what they're saying. And that's what the hobbyists and scientists were doing who eventually tracked down the source of the Russian woodpecker. They discovered that the mysterious tapping noise was produced by a single station broadcasting on extremely low frequency, or EOF. It was a massive transmitter hidden in plain sight deep in the Ukrainian forest. In fact, it was so big that even casual passers-by probably wouldn't have noticed it. Built in 1975, it was designed to blend in with surrounding trees. Its antenna masts were covered with branches and tree stumps to disguise them as natural growth. The radar is known today as Duga, which is Ukrainian for arc. It was part of the Soviet early warning missile defense system. The idea was that if the U.S. launched a nuclear strike on the Soviet Union, the Duga radars could detect the incoming missiles and alert the Soviets. But detecting missiles that were flying over the horizon proved difficult, not only because of the unreliability of low-frequency waves, but because the radar's location was secret. The Soviets didn't want the West knowing that they had early warning capabilities. So they disguised the location of the radar. That made the detection of missiles even more difficult. By the time the radar received a signal, the missiles could already be approaching their targets. To solve this problem, the Soviets needed to increase the distance between the radar and the horizon. This is called the radar horizon. And to increase the radar horizon, you need to install the radar farther away from the Earth. But how do you do that? Well, the answer was found in the upper atmosphere. Using low-frequency radio waves that bounce off the ionosphere, the Duga radar could effectively see over the horizon. That's how the radar worked. But why did it produce a tapping noise? That was the result of a transmission anomaly. Researchers now think that instead of sending out a continuous signal, the radar emitted 2 pulses of radio energy per second. Each pulse was supposed to send a complete message, but they were garbled, resulting in the mysterious tick, tick, tick. But while the radar's purpose may be obvious, why it was built near Chernobyl is not. The Soviet Union had several of these radar systems, but this one was closer to the capital of Kiev and the Chernobyl plant was nearby. Why did they build such a massive structure next to a nuclear power plant? The obvious worry is that the radar somehow caused the Chernobyl disaster. There's no evidence to support this, but the timing is suspicious. After the disaster, the radar was shut down and the entire Duga complex was evacuated along with the rest of Pripyat and the surrounding areas. Some conspiracy theorists claim that the stress placed on the ionosphere by the radar destabilized the atmosphere, causing the nuclear accident. Others claim that the radar jammed safety systems at the plant, but there's no evidence to support either of these claims. What we do know is that the radar was never finished. It was plagued with technical problems, too many false alarms, plus the Chernobyl disaster probably scared the Soviets out of continuing the project. After the collapse of the USSR in 1991, the site was abandoned. Today, the massive structure stands as a ghostly giant within the radioactive exclusion zone. Some people speculate that the tapping noise is still out there, hiding somewhere beneath the hum of modern technology. As for the Duga radar, it serves as a reminder of a Cold War era when paranoia ran high and the threat of nuclear war loomed over the world. But one thing it will never reveal is the true purpose behind the tapping noise. Was the Duga radar just a Cold War relic, or was it something far more dangerous than we'll ever know? Thanks for watching. If you enjoyed this video, smash the like button and subscribe to the channel.